Welcome to The Explainer. Today, we're diving into a question that sounds like it's straight out of a movie. Does reality only snap into existence when we're actually looking at it? It's a seriously mind-bending idea, but its roots are in the very real and very, very strange world of quantum mechanics. And we can kick this off with a famous challenge from a very skeptical Albert Einstein. His question right here, it gets to the absolute heart of a puzzle that had the founders of quantum physics scratching their heads for decades.
All right, so to really get to the bottom of this, here's our game plan. We're going to start with a huge historical deadlock in science, then we'll jump to the one experiment that changed absolutely everything, explore the kind of mystical interpretation it inspired, and then we'll finally land on the modern scientific view that clears up the confusion.
So our story really begins more than 300 years ago with this massive disagreement between scientists about, well, what light actually is. Was it a stream of tiny little bullets, or was it more like a flowing wave in the ocean?
For centuries, this debate just raged on. I mean, first, Newton's particle theory was king. But then, in the 1800s, a bunch of new experiments seemed to prove no, light is definitely a wave. Case closed, right? Wrong. In the early 20th century, new discoveries, one by Einstein himself, ironically, brought the particle theory roaring back. It was a complete scientific contradiction. So, by the 1920s, the evidence for both sides was just undeniable. It was a 2-2 tie. Physicists had to throw up their hands and accept a bizarre new reality. Somehow, light was both a particle and a wave at the same time. It had this dual nature. And just when they thought things couldn't possibly get any weirder, a physicist named Louis de Broglie came along and proposed something even crazier. He basically wondered, okay, if light waves can act like particles, could the particles that make up solid stuff, like electrons, also act like waves? This wild idea led scientists to test it, using what is now the most famous and probably the most reality-shattering experiment in all of quantum mechanics. So here's what they found, and this is where it gets strange. First, they shot electrons through a single open slit. They acted exactly like you'd expect, like tiny baseballs, forming a single solid band. No surprise there. But then they opened a second slit, and suddenly the electrons started acting like waves, creating this striped pattern. It's as if each electron was somehow going through both slits at the same time. And here's the real kicker. As soon as they put a little detector there to watch which slit an electron went through, the wave pattern completely vanished. The very act of observing it forced that wave of possibilities to collapse back into a single, boring particle. This result was so profound, so unexplainable, that it led some of the founders of quantum mechanics to a conclusion that really seemed to blur the line between hard physics and, well, philosophy. This idea became known as the Copenhagen interpretation, and it basically suggested that before you measure it, a particle like an electron doesn't exist in any one place. Nope, it exists as a wave function, kind of like a smear of all possible locations. It's the active observation that forces this cloud of potential to collapse into the single, definite reality that we actually see. And what's so fascinating is how this brand new, cutting-edge science started to sound a whole lot like ancient mystical traditions. I mean, you have this Sanskrit saying, as the vision, so the creation, which suggests our perception literally shapes our reality. The exact same idea some of the world's top physicists were now seriously considering. So in this view, the universe at its most fundamental level isn't made of tiny, hard bits. It's more like a fluid, an interconnected web of pure possibility. The solid world we see around us is a kind of illusion, or Maya, and it's our conscious mind that acts as the observer, turning that quantum fog into the concrete world we experience every single day. For decades, this interpretation was wildly popular. I mean, it suggests our minds literally create reality. But it also left this huge, glaring question. Is a conscious mind really the special, magical ingredient needed to make reality snap into focus? Or is there something else going on? Okay, so now let's jump forward to the modern scientific consensus, which gives us a much less mystical, but honestly no less amazing explanation for why that wave pattern just disappears.
Today's explanation is called quantum decoherence, and what it says is, you don't need a conscious mind to observe a particle. any physical interaction with its environment. A photon of light bouncing off it, an air molecule bumping into it, that counts as a measurement. And that interaction is what messes up the delicate wave-like state.
So this is the crucial point right here. We've basically replaced the vague, magical idea of a wave function collapse with the precise physical process of decoherence. It's not a mind that forces the choice, it's any physical interaction at all. Observation is really just another word for interaction.
Here's a really great way to picture it. Imagine those electrons are like a group of dancers in perfect sync, all moving together as one beautiful wave. The detector in the experiment, it's like some outsider who just starts randomly bumping into them. That interaction immediately breaks their perfect rhythm, their coherence, and they all fall out of step, moving like a jumbled mess of individuals instead of that one coordinated wave. And this finally solves our original mystery. If everything is made of these weird quantum waves, why is the chair you're sitting on solid and not some blurry cloud of maybes?
The answer, well, it's just a matter of scale, a ridiculous, mind-boggling scale. A single tennis ball contains roughly this many atoms.
Yeah, that is a 10 followed by 24 zeros, an almost unimaginable number. And that number, that is the key to this whole puzzle. See, every single one of those atoms has its own quantum wave nature. But, and here's the thing, they are all constantly bumping into each other and being bumped into by air molecules, by photons of light, everything. With trillions upon trillions of these interactions happening every single instant, their individual waviness gets completely scrambled. It averages out. The decoherence is so fast and so total that the object as a whole just behaves like a solid, stable thing in one specific place. So you see, it's not that there are two different rule books, one for the tiny quantum world and one for our big world. Our familiar, solid, classical world is simply what the quantum world looks like when you get a massive number of players involved. It's an emergent property, born from the law of averages. So what's the big takeaway? Modern physics shows us that reality isn't created by our consciousness. Instead, the solid world we all know and love emerges from a deeper, weirder quantum reality through the very physical process of decoherence. It might be less mystical, but it reveals a universe that is far more interconnected and wondrous than we ever imagined. And it leaves us with one final thought. What other incredible secrets are hiding just beneath the surface of what we call real?
Health is the most precious gift. If this video helped you or someone you love, please like, subscribe, and share so more families can stay safe and healthy.